Hello Cloud Growers and welcome to this brief lesson where I'll be talking about column family databases. Now, as the name suggests, the difference between this type of database and traditional databases is how the data is stored and grouped, i.e. by column and not by row. So consider the following example: a standard row-based database storing personal information. Assume there are hundreds of millions of rows in the database. In a row-based database, at a conceptual level, the data would be indexed on the row key, i.e. the ID, but stored on disk or in memory in row sequence order. So the data for the following structure would look something like this. So you have the ID, and then you have the next item in the row, next item in the row, next item in the row, and so on. And that would be how the data is stored, both on disk and in memory. In a column-based data store, the data would still be indexed on the key, but the data storage would be in column arrangement. So in this example, you would have all the first names, and then all the surnames, and then all the address ones, all the address twos, and so on. So how does this differ in practice? Well, let's consider a few use cases. Firstly, a query that needs to look at females who were born after 1960 with a row-based database. Every row would need to be read, performing checks on the values in the sex and date of birth fields to determine which rows met those criteria. In a column-based database, only the sex and date of birth columns are checked, with the rest of the data being irrelevant for the particular query. But what about another query? If we need to process a single row, let's say we need to update a few values for Malcolm Appleton, say his address, then with a row-based database we can locate the row and update only that row. With a column-based database, you need to read through locations in 2 or more columns to achieve the same. Let's look at a third use case. Let's assume you need to process the date of birth values for everyone in the table, all 100 million items. With a row-based database, you would need to read every single row and all its associated data, whereas with a column-based database, you would just be reading the date of birth column. Now, all of these are pretty extreme examples, and they're designed to illustrate the advantages of the different database types, but it should be pretty clear that each database type has specific advantages and disadvantages, and let's look at some of these. First, let's look at row-based databases. Row-based databases are much better for iterative or single record processing. If your unit of aggregation is a row, where this represents an object, a person, or a thing, and if you only ever need to store or query data on the aggregate, i.e. you don't use any aggregate functions in SQL or any other language, then row-based databases are likely to be much faster for your needs. Now, it's better for smaller databases where you won't get the storage and efficiency benefits of a column-based data store. Row-based databases are not ideally suited to large-scale or high-frequency row subset queries, i.e. where a few fields are required over every row, or where the SQL aggregate functions are used, as these will need to go through every row to get the data required, and they'll waste data retrieval allocation. So let's move on to column-based stores. These offer more efficient data access if you don't operate at an object level, i.e. if you need to update values across objects and aggregates, then a column-based data store is more efficient. For large-scale data sets, column stores offer much better data compression, as the values stored in columns are of the same type and often has very few distinct values relative to the amount of raw data rows being considered. Column store databases offer partitioning or parallel processing improvements. Columns can be partitioned either individually or in groups, and these can run on several discrete nodes. Even in single node configurations, the database platform can partition queries so that dedicated resources handle processing of operations on specific columns. In one sentence, column family databases are generally used when huge quantities of data need to be stored for later aggregate-based analysis, or when the type of data or the operations that you use immediately suit the architecture. Well, that's the end of this brief lesson, Cloud Gurus. If you do have any questions, feel free to reach out directly or via the Cloud Guru forums. Otherwise, feel free to complete this lesson and move on to the next, where we'll talk about graph databases.